All right, guys, welcome to today's video. This is one I've been hinting at for a while. It is making this 7K RPM work. All right, for this project, you're going to need a couple things. You're going to need the inlay, but you're also going to need the latest version of IPC Hammer, which is free. It's on GitHub. I'll have the link down in the description. You'll need some sort of tool to connect your instrument cluster to the computer for PCM Hammer, or IPC Hammer, sorry. The OBD Link LX works. There's a couple of other tools that work. I'll have a link in the description for that. To buy the inlay, you can talk to these guys, Amarillo Cluster Repair. They're the ones selling it. He also can sell you one of these kits like this that'll let you hook up nice and easily where you don't have to wire it in yourself, because if you use this, you're gonna have to get the pin out, wire it in yourself, and take care of it. This does all that for you. You just plug it in and you can use it. All right, so that's the overview of the tools and supplies you're gonna need for this. Now, this currently we only have the inlays for the 2003 to 2005 ones. There's not inlays for the 2006, 2007 that do go to 7K yet, but the firmware does support it, so you can do the 7K RPM with 140 mile an hour and trans temp from 2003 to 2007 Classic. I'm going to be showing you guys how to do it on a 2003 to 2004 circuit board. That's what I got right here. All right, so we're not going to need to add any hardware to this. This one's already been rebuilt. I've actually used this for a couple of other videos. This is just like, this board gets tormented on the channel because I keep it around. But yeah, so we'll be putting 7K on this one already. If you don't already have the trans temp stepper motor, just add the stepper motor. And you'll be able to add it into the features once we get into doing this. So if it wasn't already operational, because, you know, sometimes on the 2003s, they're already programmed for trans temp, but I'll be showing you how to program it for trans temp, the 7K RPM, and the 140 mile an hour speedometer, all in this one video. Okay, so before we get into this, let's actually just take a quick look at how we got it set up. First little disclaimer I want to put into this is that IPC Hammer is still experimental software, still working on it, so there is a chance that you're going to brick the microcontroller from being able to respond over the class 2 serial, and that you may actually have to go in and use, you know, something that you can hook up COM port to it, and then use Minimon and go in there and actually reflash it manually. So if you do brick it, you can recover from that. I have other videos on it, so just look up some of my other videos. I made to put them in the link in the description on how to connect to these and use Minimon to reflash this if you do brick it. So just be aware of that before you get into this. So if like this is your only instrument cluster you have and you can't afford to replace it, and you're not comfortable trying to learn how to recover from a brick, then I would say don't do this. But really, it's not that hard. It's really not difficult to recover from a brick. You just have to be willing to put in some effort, because this is free software. Nobody owes you anything to try to fix it. So, you know, you're on your own. You know, I'm not trying to be mean or say, you know, you're stupid. I'm just saying, you know, disclaimer, people that work on these projects, they're doing this in their own free time and they're not charging you money for it. So don't expect any sort of service back out of it, if that makes sense. And I'm saying that because I have had people complain already, and it's like, what's wrong with you? But yeah, let's get back into this video. Let's focus in on what we're doing here. So overview, what you have, you just have your 2003, 2004 circuit board, and you have it plugged in via this connector to this guy, or you have it hand wired in. So if you were to hand wire it, you would just have your connector that you pulled out of the truck. You'd have your power cables, and then you would have your COM, and you would just wire it in to this guy, sharing your power and your ground to that, and then COM. So that's all there is to wiring it in and getting it hooked up. If you need the pin out of that connector, just get on Google. It comes up really quick. Plenty of people have uploaded that particular pin out, so definitely just Google it. It comes up. All right, so now we're set up, and that's all we need to do hardware-wise, is get it plugged in, get it powered up. Now we can connect to it on the computer, so let's go. All right, so now we are connected. Let's go ahead and do a read properties to it. We need to do that because we want to put the same calibration ID back onto here. So yeah, we are going to write calibration, but we're going to put the same one in, if that makes sense. So we're just going to do a calibration. We don't need to change the operating system and calibration, just the calibration. So write calibration is what you're going to click, and then it's going to give you that same warning I just gave you that you can break this. So yeah, tough shit if you do. All right, so we needed 15130.769. Let me just verify that I'm remembering correctly. Yep, so that's our calibration ID. So click open. All right, so now we want the 7K tack, and we want we need to select this because this is for 03 and 04. In 05 and 07, you're just going to use modify options, but this one we do actually need to click this. So select these two check boxes to make it a 7K with 140 mile an hour. And then click continue. And now it's actually writing to the calibration of it. As you notice, the screen went off. Hopefully you can see that on the camera. And you can see it going there. Since we're just doing a calibration, it's much faster than an operating system plus calibration. And for the most part, you're only going to be writing calibrations anyways. So yep, there we go. We've now successfully written it to it. Let's go to the modify options and make sure we have trans temp turned on. So we're going to go for trans temp. Yep. We have trans temp turned on because if it was checked, it would be no. Trans temp off, it's on. Okay, and then this is 05, and then 05. Yeah, so the 05 through 07 to get the 140 mile an hour, all what you have to do is check that box. But since this is a 2003 and 2004, we should have it correct. So now let's go in and actually put the cover back on here, put some needles on there, hook it up to the function generator, and put some pulses and verify that those work. I guess before we do that, we will verify that our trans temp is working too. All right, so we have a needle on there. Let's go ahead and do test instrument cluster. Yep, there we go. We can see that the trans temp is working. If it's not programmed for trans temp, it won't sweep. Okay, so let's verify that this is working. I already have the signal generator hooked up to it, just at 15 right now. So there we go. You can see that it is actually hooked up and not just randomly sitting higher. All right, so let's turn this back up. All right, so it's roughly 33.3 hertz per 1,000 is what you got. So right now we're sitting at 35 hertz. It's just a hair over 1K RPMs. So let's verify that we can make it all the way up to 7K. So we're just going to go ahead, and it should be roughly 235-ish. And yep, there we go. We are there. So we do go all the way up to 7K, which is roughly 235 hertz. So let's go bring it down to 6K, which should be like 195-ish. So yeah, we're just a hair under 6K, but let's bring that the rest of the way up. Should be like 200 hertz, should be right at it. There we go. So we are directly on 6K RPM. So let's go ahead and shut down this instrument cluster. We still have the signal generator on that. And let's take one of our regular 6K RPM instrument clusters and just verify that our numbers are the same. And there we go. And we'll just get up to that 200. All right, so that's 205. So let's bring that down just a hair to 200. There we go. And we're still on 6K. And let's just kind of bring it down 10 and go back to 1K. So yeah, 1K, just a little bit under at 30. So let's bring it up to, there we go, 30. 33 brings us directly on to 1K. So yeah, it's roughly 33 hertz per division on here. Well, per 1K, I guess, not per division, but per 1000 hertz. So that way, if you're trying to actually use this for something else and you need to generate signal, yeah, square wave at 50% duty cycle, 33 hertz, and 8 volts peak to peak is enough. And it's really supposed to be 12 volts, but just 8 volts works, so I'm using 8 volts. So yeah, so we can verify that our tachometer's accurate. Now let's do speedometer, and let's hook into this guy. That's our speedometer. All right, so let's just bring it up to 60 miles an hour. All right, bring it down. Go up here. All right, so there we go. So 65 hertz has us just a hair. Let's go 66 hertz. There we go. That gets us right on 60 miles an hour. So let's try that on the other instrument cluster and see what we get. All right, and we are right on 60 miles an hour again. So sure enough, it works. And that's looking at it from right here. It's right on 60. I get that y'all have a different angle, and so you have parallaxing with the needle, so it doesn't look like it's straight on looking down from the camera when I look over at my monitor for it. But it's dead on 60 miles an hour. So our speedometer is accurate, which means we'll be able to go up to the 140. So let's go ahead and do that. 140 miles an hour. So we are at 140. Let's go back down to 120. See here. It's a little bit high. There we go. Right on 120. Let's turn this off and put it back on the 120 mile an hour. So that was what I changed it by 1 hertz because it was just barely past 120. So I went down one hertz there, and it's now right on 120 there. So I mean, yeah, that's hardly a difference at all. So definitely the 140 mile an hour speedometer is working, and it's accurate. So I would call that successful in that it does work, and that's on a 2003, 2004 circuit board that we did that to. Well, I hope you guys liked this video. I know there wasn't much soldering or anything like that going on in this video. It was all software, but hey, we got this to work, and that's pretty cool. What I really like about this whole project right here, though, is that it ties in that reason why we should be able to get the data off of the microcontrollers on stuff is that allows us to create, you know, new firmware. I didn't do this. Mike made that. So Mike made that firmware to work so that way you could do the 7K RPM on here. That's his own work, and that's through being able to have access to the microcontroller's firmware to make that happen. So yeah, I think what Mike did was really cool. I think it's cool that they're getting these custom ones printed over there and selling them. So definitely check them out, and you can, you know, do this modification yourself. It's really not too complicated. The main thing to be aware of is just you can possibly brick the instrument cluster, but bricking it doesn't break it. So it's not permanently broken when you brick it. You can still recover from that. You just can't do it over the class 2. You have to put the microcontroller into Bootstrap Loader and then connect to it via UART, and then you can just write with Minimon. So it's really not like you broke it permanently. It's just, you know, there's a risk there, a little bit more skill involved. Not a whole lot. There's just some soldering. You're going to have to solder some bodge wires on to be able to connect to it. This is a solderless project as long as you don't brick the instrument cluster. So make sure you read properties and write the same calibration back onto it. That way you don't, you're less likely to brick it by putting the wrong calibration on there, and you're less likely, and then you have all the same features too. So yeah, I hope you guys like this video, and I'll see you guys in the next one.